Hello everyone and welcome to another video. This week's video is going to be analyzing heat and Alzheimer's disease. In summary, can heat be protective against AD? So we'll find out. So before we begin with the paper, I'm just going to present a few things for one individual that this paper will be discussing. This individual comes with presenilin 2 gene mutation, ApoE4 mutations. Basically, they are designed to have early onset Alzheimer's disease. This person also has heat shock proteins, which are responsible for protein homeostasis and ensuring that all the proteins are doing what they're supposed to be doing. Another thing that you should also know here is that PP2A is a dysphosphorylating enzyme to tau proteins, thus reducing their chance of causing pathogenic problems. So basically, the case study is of a person who has a genetic countdown whereby everyone in his family immediately started showcasing Alzheimer's disease behaviors by age 54. So the scientists were basically looking at this person until he reached age 54, and by the time he turned 54, he walked out still being himself with no problems. Continued to live on in regular day-to-day living without any problems until he was about his 70s, when they looked at his brain and they saw that he had a substantial amount of amyloid buildup, but he didn't have any tau phosphorylation happening. So what happened? Well, this paper will basically explain what happened. So the name of the paper this week is called Lifelong Heat Exposure as a Potential Contributor to Alzheimer's Disease Resilience. We have the authors listed over there, and the journal is called Sage. And this paper was published in 2026. So basically, the paper was postulating that the reason why this person was able to go into his 70s without any kind of behavioral changes to his personality and not showcasing any Alzheimer's disease pathology, despite having substantial amyloid buildup in his brain, was that the fact is that this man was exposed to a lot of heat, a substantial amount of heat, actually. So before I explain exactly how this happened, I'm going to just kind of postulate a couple of things about Alzheimer's disease. So when it comes to amyloid, you have to think of amyloid as something that basically just provides the matches. It provides the matches, and then we have another protein called tau, which basically will light the fire. Once tau gets going, usually you see a lot of the behavioral changes that come with Alzheimer's disease. All the pathologic problems, the brain shrinking, all those big disasters that happen within the brain are usually caused by tau hyperphosphorylation, especially with the Alzheimer's disease context. So basically, amyloid provides the matchsticks, and then tau is the fire that lights up the entire brain, showcased by this image as well. So usually tau is it's within the axons of neurons, the axis bridge, and when it starts going crazy, usually you can understand that usually amyloid plaque is in the external of the neuron, and this tau is within the internal of the neuron. So if all neurons are starting to exhibit this hyperphosphorylation within themselves, they'll start shrinking and incapable of doing their function, and then that can be passed on to the next neuron, showcasing this analogy of how tau essentially just spreads the fire. But when it came to this specific case study that we're talking about, the scientists found out that he had essentially had tau build up within his occipital cortex. Everything was basically stable, was still specifically stable, and nothing spread extensively into his memory and association networks. So basically, they found that this guy was, even though he had the amyloid burden that is characteristic with the people who carry the genes that he's carrying, he still was cognitively intact. He was still able to do his activities of daily living without any problems, and he was essentially, in all accounts, matching people who were in his age, doing the things that they're able to do without any problems. So this person basically worked in a naval engine room for about 20 years of his life. And in this naval room, it can basically reach temperatures of about 50 degrees Celsius. And this can, in essence, cause the body core temperature to go up 1.2 degrees Celsius. Let's just to put that in perspective, like, you know, your body temperature always has to stay at a certain amount in order for things to function properly. If it goes higher, usually that's considered a fever, and if it goes lower, then you know it's you have the chills, and you're just not generally in good shape. So your body temperature has to maintain its specific a specific number at all times. So this person, however, was increasing constantly his core body temperature by 1.2 degrees for 2 hours. So this definitely did bring a change to his body. It basically introduced a lot of heat shock proteins within his circulatory system, specifically his nervous system. And these heat shock proteins are what the scientists are postulating is the reason why he didn't basically go into the pathways that people who have the genes that he has usually go under. When these heat shock proteins are activated, they would essentially bring the homeostasis for proteins. What does that mean? So they are responsible. I think I explained this earlier when I started the video, but they are responsible for protein homeostasis, which means that they control the folding of proteins, the clearance of misfolded proteins, and the dephosphorylation of proteins. A prominent bisphosphorylator is PP2A, and that's what the researchers were looking into, and they found out that PP2A um, is actually works best under conditions of heat. So when you introduce heat into an environment, PP2A is more likely to work, as opposed to the if the person is basically when it's cold, PP2A does not work as well as when it's hot. So yeah, so these heat shock proteins basically just kind of come in and are like cleaning crews, and they ameliorate and ensure that this phosphorylation doesn't happen. Now, despite the fact that there was amyloid buildup, this just means that this isn't an end all be all problem. It's not like causing the complete and utter demolition of the disease. It just kind of gives that person a couple more years to have live a relatively stable life. But this was just brought on by the fact that this person was constantly um, in a very hot environment. They also the researchers also highlighted another study that was done in Finland, where they basically took about 2,000 people, and they looked at them for 20 years and found out that those who were staying in the sauna for about 3 to 4 times in a week, they had about a 20% decrease in their Alzheimer's burden. However, we got to take this with a grain of salt, because we don't know. Usually people who are able to access these things tend to have better health overall. So it's not something that you can consider as a cure yet, but it's just something that you can be informed about. But in summary, basically, it seems that heat may be a modulator for ensuring that our brains are in stable conditions. But there are some things that we have to also take into account based on all this good information I'm telling you. But we have to also take into account that the researchers have not shown that heat causes resilience. Sauna bathing prevents Alzheimer's. Heat can stop established dementia. Heat exposure produces the same effects in humans as in mice. More heat provides greater protection. A specific temperature, duration, or frequency is safe and effective. We don't know any of these. We just noticed one case study and kind of postulated these hypotheses based on this person, but it doesn't mean that it's the cure, essentially. So, all in all, I created a little visual to kind of put all these together, thanks to Grok. So just stick around and check it out.
Within the human brain, Nora the neuron observes the cleaning crew at work. Heat shock proteins act like a cleaning crew, clearing out debris. They gather the tau tangles and dispose of them into the cerebrospinal fluid. The waste is then excreted from the brain.
Alright, everyone. Thanks very much for watching, and please leave a comment and let me know how I can improve these videos, make it more interesting. And thank you and take care.